So I'm going to take 5 minutes as it's a short talk. My name is Raphael Pinson. I'm an infrastructure developer working at Camp2Camp. I've been involved in the Puppet community for a few years, but I started using Puppet around 2007, and I've been mainly involved in the last 8 years in the Puppet community. I'm currently one of the main OGS developer that's involved in the Puppet community and maintaining the OGS Providers project. I work for Camp2Camp, which is a company based mainly in Switzerland, France, and Germany, and we've been really involved in the Puppet community for years. So let's talk about certificates. I'm guessing for a lot of you it has happened. You install Puppet, and then 5 years later, well, the CA certificate has expired. So what do you do when the CA certificate has expired? There's different options to renew the CA. Well, first you could try getting a new CA key pair. Sometimes that's necessary. It's happened to us recently where our CA was so old that the key pair was not strong enough, and so OpenSSL was complaining. But most of the time, you don't need to do this. So you can actually create a new CA certificate from the existing key pair and just renew the CA this way. And then you could actually automate the CA certificate deployment and even make it so that the agent certificate deployment will be automated as well, so that your agents can get their certificate signed again when necessary. So what's important is really planning ahead when things like this happen. You know it's going to happen in 5 years by default. So and usually 5 years is the thing is that it's long enough that you don't remember that it has to be done, but it's short enough that it will happen sometime soon. So you need to think about it. There's usually warnings as well that you can see if you're actually looking at the warnings in your logs. So Puppet Labs has a standard module for this. It's called CertRegen. CertRegen, actually, there's a mistake on the slide. So the module is called Puppet Labs CertRegen, and with this certificate, when you install it on your Puppet server, you can actually regenerate a certificate with the same key. And so these are the comments that you can use. And you can actually use the CertRegen client, CertRegen client class to deploy the new CA cert to the agents. So you need to do this before it expires, obviously, because this means that your clients will get the certificate in advance, and they'll be able to trust this new certificate. And then when you switch to the new, when your certificate on the CA expires, then your agents are already ready to trust your CA. But what about the agent certificates? Usually you don't need to deal with this because if you renew the key, then, well, you need to re-sign all your certificates anyway. But once you renew the certificate without renewing the key, then your agent certificates that are also valid for 5 years will start expiring. So you need to patch this as well and find a fix for this. What you can do is use the auto-sign policy. Using auto-sign policy makes it possible to use a script to sign your certificates automatically. So the agents can generate certificates, send them to the Puppet CA, and they get automatically signed based on some secret that you share between the agent and the CA. You can have a look at Daniel Dreyer's Puppet AutoSign, for example. And then there's a type that has been created that is called Puppet Certificate, which allows to actually automate the Puppet certificate generation and management. So this type we patched a few years ago, but it would actually allow to automatically regenerate the certificates on the nodes. In order to do this, obviously the nodes need to clean themselves on the CA. This is not done by default, but in the auth.conf, the configuration for the Puppet server, you can allow it. Here, we've set it up so that the certificate status requests are allowed to be executed with the delete method for the certificate itself. It means that nobody can actually remove certificates from the CA except the CA certificates, the certificates themselves. So nodes are allowed to remove themselves from the CA, which allows them to automatically renew themselves. And then the next problem is, how do we make it so that they can renew themselves with a secure token so we don't store a secret, a shared secret, a PSK on the agents? And in order to do this, we came up with a way to hash the certificate, something like this. We have a PSK that is shared, and then the cert name of the machine, and then we generate a a hash based on this, and we store this as the secret in the certificate request. And then on the master, the autosign script will generate the same secret based on the PSK that is known and the cert name that is requested, so that this way, when an agent requests a new certificate, since the PSK is not stored on the agent, the only thing you could do as root on this machine is renew the certificate for the same machine, and you can not do anything else on this. You cannot request a certificate with some other name because there's no way to find out what the PSK was by reverse engineering it. And then you can throw a certificate extension as well, and that's how we do it, by getting the extension, so the CSR extension, which attribute which allows to pass the secret to be auto-signed. Now, if we couple this with an extension like PP role, for example, for automatic provisioning, instead of using server-side provisioning, we can provision using the agent. And so if we put all this together, we can have a CSR attribute that contains the token that is generated using the hash, that contains the role as well. And then we can generate the token based on the role, the PSK, and the cert name, so that when the certificate is renewed, it can only be renewed for the same cert name and for the same role. And then on the Puppet server side, we have this Puppet certificate type resource that allows to manage the certificate. And here we have a wait for cert, so that when it renews the certificate, it can wait for 60 seconds. And there's a renewal grace period, which is in days. So 20 days before the certificate expires, if Puppet runs and finds out that there's less than 20 days left, it will automatically clean up the certificate on the Puppet CA, renew the certificate locally, get it signed, and then finish the Puppet run with a valid certificate for the report. So goal is achieved, and what's great is that it could allow to have let's encrypt kind of approach to Puppet certificates eventually. So the second one is about OGS providers. So as I mentioned before, I'm an OGS Providers developer. This is what this is about. There's lots of fine manipulation options in Puppet. There's lots of different tools. You can use file for content or source or template. You can use concats as well if you need to put things together. You can use fileline. So what is the best approach? Should Puppet manage it? Then you should, if it's a software or script, then maybe it should be packaged. If it's a binary or data file, then Git plus VCS repo type should be the best option probably. If you need to manage the whole configuration, then in one context you can use file. In multiple contexts, you can use empty directories or concats or native resource types with purge. I strongly recommend Craigdown's purge module, which is excellent and very flexible. But if you need to manage discrete configuration entries, then either you can use the conf.d directory without purge or native resource types without purge. But native resource types, there's not tons of them that can actually manage files. So there's host, there's mail alias, which are historic types. There's the ini setting for INI files. But what are the formats? There's the option of fileline. But fileline, if you come from the CF Engine world, with some of us have suffered through the CF Engine world with editors no such line and things like this. You know that the results of the fileline approach are usually very questionable. You can break files in a pretty bad way by editing single lines without a proper parser that takes in consideration the whole file. So OGS is a project that was created in 2008 as a generic C library for configuration edition. It's like a scalpel of configuration edition. There's bindings in many languages, and because the person who created OGS, David Luttercourt, was really involved in Puppet from the beginning, there's been an integration of OGS into Puppets very early on in 2008. There's more than 300 parsers that we call lenses in OGS that are available, and so you can parse tons of different configuration formats using this library. The OGS type in Puppet has been included since very early versions. It's not included in the core anymore in Puppet 6. It's included in the module that is called OGS core. And it's fine for simple cases where you just need to set a value. But as soon as you need to do very complex things like inserting values and positions, for example, it's hard to make it idempotent. So you'll end up with very complex logic that is hard to maintain, if at all possible. So the OGS Providers that was started by Dominic Cleal a few years ago is a library to provide native Ruby types for Puppet that are based on the OGS library. It provides a declarative API, so you can build your own Puppet types on top of OGS. It currently features about 20 different types and providers, plus some that are provided in other modules using the library. So you get benefit from the OGS power and flexibility, but you don't actually need to know how OGS works. It hides all the complexity of OGS into standard modules and types and providers. So here, for example, if you take the shellvar type, this is based on OGS. It uses OGS internally, and it allows to position variables such as port here inside the etc default puppet master file, and then you can specify that you want these three values as an array. So the type takes care of all the complexity of calling OGS and setting the tree properly. There's lots of types that exist for Apache, for kernel parameter, for Grub, PAM, shellvar, SSH config, and so on. There are a few examples. You can use shellvar here so that the variable is present inside a target file with a specific value. Here, the array append is pretty cool, is that it will parse this value as an array of values, and it will make sure that this value exists without touching the others. If you didn't put this, then this would be the only value in the array. Same here with SSHD config, where you can actually manage even match groups inside the SSHD config by providing a condition. You can use in your Puppet code, just install the modules like OGS Providers, SSH, or OGS Providers, Nagios, for example, and then use the types directly as native Ruby Puppet types. You can also purge them. Most of them are purgeable. So if you use CrayfishX Puppet Purge, you can easily manage your SSHD config file entirely by managing only the entries you're interested in and purging everything else. You can extend it. The library is extensible, and you can make your own types based on it. I'll pass quickly on this. These are details on how to extend and how it works. And Narcissus is an equivalent of OGS Providers in the Go world. If you're interested, if you're writing tools in Go and want something similar, this library, which is for Go reflection with OGS, is available as well. Thanks. I don't know if there's questions on this.
There's a question that just came in that I think was for your last talk, and I'm just going to read it out. It says, the provision that the server can delete its own cert, is it available for latest release only? I'm not quite sure that I follow the question completely.
What is it? Can you repeat the question?
The provision that the server can delete its own cert, is it available for the latest release only?
Okay, so it's not really the service doing their own certs, it's the agents. And it works for every version of Puppet, really. It's just the auth.conf, which allows you to decide which parts of the API are accessible by agents and how, or by certificates and how. And so you can use the auth.conf of your Puppet master to decide that an agent is allowed to clean its own certificate using the API. That works with pretty much all versions of the Puppet 7, or even older.
Hey, name is Yoke, like the flight stick. Hey, so I want to talk a little bit about what we have in progress over here with using Step CA, which is a small piece of software by Small Step. You can find more info on that at smallstep.com. We are using it today as a external CA. It was very fun to set up. We're just going to walk through the infrastructure and what we hope to accomplish with it. So we are managing both servers in AWS and then endpoint desktops style systems. So we have to essentially have Puppet on the internet. So one of the concerns that we had is we wanted to make sure that nothing was accessible on the Puppet server itself unless you really had a certificate ahead of time. And StepC allows us to do that and bootstrap the client's certificate even before Puppet is installed, technically. So we are we started with setting up the CA in AWS. We exposed that through the internet. It has a number of features that are very interesting. One of them is that it can manage certificate for SSH users and use G Suite for authentication of the users, which allows us to get to allow specific users to do a bootstrap on their desktops, for example, and pull in certificates that are managed on the server side on the step CA itself for their system, which was a very interesting feature that we ended up using. And then as part of the Puppet side, we set up a Apache server to do the MTLS termination. And then we have a couple of Puppet servers, compile masters behind that, that are essentially handling the catalogs and everything else. One of the interesting features of StepCA is that it can use Acme to refresh the certificates. So all you have to do is just run a command on a regular basis when the system is online. And in theory, it just replaces both the key and the cert on there using the same subject name. And that seems to work just fine with the infrastructure we set up.
So Corey's been working on the Puppet debugger for quite some time. It was probably the first shell that let you drop into like the internals of Puppet and sort of like poke around and run code interactively the same way that you might with a shell like IRB or Bash or something like that. And he's been maintaining it, keeping it up to date over the years, and just recently added it to the PDK.
All right, so what I wanted to show you guys is, first of all, this is the web page for the Puppet debugger, and I think there was a small introduction, but it's a command line tool. If you've ever heard of pry for Ruby, that's exactly what this does. It allows you to inspect your Puppet code. And since a bulk plan is Puppet code, we can actually use the same tooling for bulk plans. Now, what I have here, and this is going to be an kind of an interactive demo, is I have a failure that I just found out about yesterday, and I wanted to go through this with you guys. I have a simple test that's going to exercise my plan, and this is the plan that I have. It's basically going to gather some data, and it's going to merge all that data together. But it's failing. So let me show the failure here. When I run the test, I actually get this line. Now, that's not really helpful, except for that Puppet's nice enough to tell me exactly where it's failing, but I'm getting this operator bracket error. And it says it's on line 23. So I know it's something to do with this code right here. Now, this previously worked, but for some reason when I ran it yesterday, it didn't. I suspect because software changes frequently that it's going to break stuff. So when I run this, I go ahead and run this. I'm also using a debug break symbol. And what that allows me to do is break into the Puppet code as it's compiling it and allows me to inspect everything. So we're going to break into this code and inspect what's going on and just give a little demo of what the Puppet debugger can do. So I'm also using PDK, and I'm running this specific test. Okay, so if you guys can see that, let me just bring this up here. I'm now inside the Puppet debugger, and if I look at the results, which if we pair this back, it is currently braked right here. I'm going to just look at this variable. It's going to be a lot of output. This is all that data that comes back from running that specific task. And I can look inside this, but I think it's like over 1,000 lines. But where I am right now is I'm actually on line 21, and I am in a reduce function, which is a block of code. So I can look at the value of res, which is basically the aggregated values, or I can look at item. And so as I loop through each iteration of this block, I can get the value of item as it'll be different. Now, where it's failing is right here. So I'm going to take this code and just copy it and replay it back here, and we'll see where this error is occurring. So that is the error that we saw earlier. Now the question is like, what happened to result? Where did it go? So keys is a function. I don't remember if it's part of standard lib or Puppet core, but keys is a function that gives me all of the keys of the hash. And since item is a hash, I can see all the keys. And what we see is that result is not one of them. So I'm just going to go through these real quick. See that status, success, target. That is the system that it ran on. That's not very helpful. And let's see what object is. Object is nothing. But value, that's the data that I want. And then I'm also going to add output to see what the output is. You can see this is the value that I actually wanted in order to have the same result. So in this case, since result has actually changed to value in a recent version of Bolt, I'm simply just going to paste this into here. And I'm going to take this down here, put this here, and I'm going to replay this test. And I should be able to make it about this. Now, as I said before, we're iterating through each block. So every time I type exit, oops, well, it failed, so that's not going to work. But usually every time you type exit, it will go to the next block and you can see the values. So we'll try this again, and we'll get further than we did last time. All right, so I am now here, and what we're going to do is just look at the stack status variable. And you can see that this is all the aggregated data that that looping structure produced. And we are inside of a plan, as you can see here. We can actually look at any variable that we want. But this works the same as a Puppet class or a defined type or any other Puppet code that you can put in here. And I'm using the debug break function to break into this. So that's what I wanted to show you guys. Again, let me pull up the website here. This is a website where you can learn more. There's a pretty good docs that I have going. I think I even have one on testing data types. I've got some exercises here. I've also got lots more information provided in the docs.
And it looks like the last one up there is me, and I will just be talking at you about how to write a good README. And that's something that a lot of us developers sort of struggle with, because when we start writing down information about our project, we sort of intuitively initially just jump down to writing down information, right? Things that are informative. How do you use it? How do you install it? What are all the command line options? What are all the things, all the ways in which you can use this neat, nifty new tool that you just built? And we're all very excited about getting our READMEs to be very comprehensive and informative. But the thing that we forget about is that a lot of the people who are looking at your project, especially for the first time, they don't have the same kind of context that you do. And we don't really take that into account. We don't realize how much people don't know about what we're writing about as we're putting it down. So most people reading about that project for the first time, they're not invested. They may not even know what your project is or what it does. And if the story isn't immediately compelling, without all of that like institutional knowledge that you've got, then there's not really a lot of incentive for people to keep on reading and find out what your project does or how it's useful or all of the other really great, interesting information that you have in that README. So generally, I sort of recommend a rule. I call it the 5-30-90 rule, and it's there's lots of different variations about it, but it's really just about time. How much time is somebody willing to invest in your project? And it's broken down into stages. So first off is just the first 5 seconds. When somebody's looking at your project for the first time, if you don't capture their interest, then they're not actually going to spend any more time reading about that. So you've got 5 seconds, and they're not deciding whether to use your project. They're not deciding whether it's a good project or how to install it. They're simply deciding whether they should continue reading. So the first thing that you do in those 5 seconds is grab their attention. The first glance at the README should be welcoming. It should not be intimidating. Like if I look at a README and it's like 12 pages of like single space text with no paragraph breaks, I'm like, no, I'm done, I'm out. So when you look at the README, it should be easy to read. It should be consumable, digestible, short paragraphs, nicely spaced, easy to consume. Include graphics. If you have like a screencast or something that can immediately show what your project does, use a graphic instead of trying to describe it. And then your first couple of sentences, all they need to do is present your project as kind of like a compelling solution to an actual real problem. You don't need to be informative. You don't even need to be like pedantically accurate, because your goal here isn't to convey information, but to convey to give people interest enough to keep reading so that you can be informative. So the next, you have about 30 seconds. That's like the first bar. Once you've got them past that first bar, you've got another 30 seconds, and you're still talking at a very high level. But then you can start sharing like some kind of use cases. Talk about some of the problems that you have solutions to. Describe some of the benefits that you offer, but don't get into too much detail, because you're not talking about edge cases. You're not talking about like all the different ways, the rabbit holes that people can go down on. This is when you're trying to get people a general idea of what your project can enable. And we're not talking about features here. Like as engineers, we often think about things like in very technical matter, but in general, like details like what sort of architecture you use or the frameworks that you've designed aren't really a lot of interest for people that are coming to your project for the first time. They have a problem that they want to solve. Their problem isn't really the same as yours, so they want to know if your tool is going to be the thing that answers that solves their problem. Sometimes the framework does matter. Sometimes those things are of importance, but that's only like specific use cases. Like when I was talking about my Dropsonde tool, I think that the framework matters because this is hey, look, ignore all the technical details, but there's this aggregation thing that keeps your privacy, protects your privacy. Something like that, talking about that at a high level, that is probably reasonable to include at the beginning of a README, but you don't go into too much detail about it. And then after that, you get another 90 seconds, a minute and a half, and then you can start showing some of the complexities. You can show like examples. You can show some code, maybe some of the options, but it's still not documentation. It's not reference material, but you can sort of like better explain how your project, like what sort of niche your project fits into. Are there caveats? Are there integrations that can help amplify your functionality? If there are like architectural decisions that are going to like I don't know, affect interoperability or performance or anything, you can sort of briefly describe them at that point. And then once you've got people past that, now you've convinced them, now they're going to invest time in your project, but you still don't drop into like reference material. Your README needs, like the entirety of your README needs to be easily read, easily consumable. At this point, you're going to want to show them how to install it. You want it like a call to action. Once you've got this far, this is how you install it and move on, and then provide a link to the documentation. And then the documentation is where you include all of the, like all the nitty gritty, the getting started, the tutorials, all the reference material, etc. And now that right there is your README that does its job really well. It grabs people's attention. It convinces them that your tool is the thing that solves the problem that it solves. And then it convinces them to learn more about your tool. And then they can move forward and try it out and go through the documentation.